we have spent decades moving everything to the cloud and it solved a lot of problems. But when it comes to AI inferencing specifically, it demands a fundamentally different architectural approach. Why is the centralized cloud model not working for agentic AI?
It's a good point. And I mean, the cloud has been massively transformational for many enterprises. So the ability to rent infrastructure versus own infrastructure, the ability to consume infrastructure as a service versus as infrastructure, these have been transformational. But when you think about AI, we're going through a big transformation in terms of the types of applications that we're seeing running on top of the infrastructure. So a couple of years ago, a lot of focus was on training models. And so a lot of the discussion and architecture focus was on how do we support very large clusters of coherent GPUs so we can connect these GPUs together with very high-speed interconnects to create this large coherent cluster with high-speed interconnects between each of the GPUs so they can share the memory that's available to them. And so memory was really the constraint that we're optimizing for, and so we create these very closely connected clusters to achieve that high-performance computing infrastructure that allows us to create these amazing foundational models that we're all familiar with today. That started to shift as we put more of our focus into inference, so running workloads on top of those models. Early inference workloads were chatbots. They weren't particularly complex, and so those could be deployed into centralized infrastructure. And again, having those run on centralized infrastructure has got some values of you've got massive compute all in one location. You can often drive economies of scale there. You can drive efficiency in terms of placing workloads and optimizing usage across many users. We're at the cusp now of the next wave of adoption where we're moving into the rise of agents. So OpenClaw, I'm trying to remember exactly how long ago it was, 6 months ago, I think it kind of exploded onto the scene, really kind of started the main wave of adoption around kind of agents. And what we're seeing from our customers now is, as they're thinking about agents, these aren't sort of one-dimensional chat type applications. They're multi-stage, multi-turn applications that are they're calling tools. They're looping multiple times around these kind of inference loops. They're pulling in huge amounts of context to give the best answers possible. And physical geography is becoming a really important constraint in these architectures.
When enterprises try to force these new agentic workflow through that same legacy centralized infrastructure, what exactly breaks? Because often they don't realize it. All they see is performance hit, a higher bill, or runaway token usage. But what is actually breaking underneath?
I think that the kind of the simple answer is like, hey, the real world isn't centralized. Data, users, the devices, the APIs, and all the decisions you're making, they're distributed. When we're delivering a service in production, it doesn't all sit in one data center, and not everyone is physically close to that data center. And so as you think about what an agent really looks like, you've got a combination of the actual agent, which runs on top of CPU infrastructure. It calls out to models that are running on GPUs. Those can often be multiple models. You can have different types of models it's calling. Maybe it's calling OpenAI, maybe it's calling Anthropic, maybe it's calling open source models that are hosted on different GPU infrastructure elsewhere. So that even the models aren't all co-located. But increasingly what we're seeing is the agents are dominated by the tools that they're calling. So the power of agents is around the memory system that it's got, the access to the file system, the ability to execute code in some kind of a sandbox, generate output from the code that it's running, to call out to third parties, so to call APIs, to call MCPs, to call out to these external systems so it can interact with the real world. So this is the real power of an agent. And as it's interacting with the real world, that's not all in one location. And so this is the problem that we're seeing is Agents have to interact with the real world. That real world is distributed. Forcing all of that to run in one location means that you're compounding latency. And these agentic systems, they run in a loop, they run multiple interaction or multiple times around the loop, and you're compounding that latency on every loop. And so even adding 100 milliseconds of latency, if you're looping 100 times, that's 10 seconds of latency that you've added, which might be okay for a chatbot. Maybe a human's willing to wait 10 seconds for an answer to come back. But for physical AI, for any type of real-time system, 10 seconds is way too long. It's a lifetime.